nowhere. I'm out in this wide open space to talk to you about the wide openness of space. I want to take you on a tour of our solar system. But to do that, I need a lot of room and a rocket. And since I'm out of rockets, I brought you up here. Now what I'm going to do is shrink the size of this solar system so it will fit here. Now I'm outside of Redding in Northern California. And if you're not familiar with this area, you might want to look it up on a map because it's going to be important later on. But Redding's at the bottom of the Cascade Range, the volcanic range that runs along the western United States. In fact, I'm standing on a plateau called the Millville Plains, which is a volcanic plateau from an eruption long ago. And all the mountains that I can see in the background are volcanic in origin. So in order to fit the solar system on the Millville Plains, I have to shrink the sun. Now the sun is very big, but I've shrunken the sun to the size of this ball, just a mere 2.5 inches, about 12 centimeters across. And because of that, I'll be able to fit the entire solar system by walking out in this direction, northward. So won't you join me as we go through a tour of the solar system? Now let's walk to Mercury, 37 million miles away. I take one big step and I'm there. And look, there's the sun. That's how the sun would look from Mercury. So I'm going to put down a marker for Mercury. Look how close Mercury is to the sun. There is the sun right back there. And Mercury is this little tiny black dot that you can see in the center. The yellow one represents the size of the sun. That little tiny black dot would be Mercury. It is much smaller than Earth. So I'm going to put Mercury right there next to this cow dropping. You'll have to excuse the cow dropping. So we've gone 37 million miles. That's a lot. There's a couple of things I want to talk to you about. One is called rotation. The other is called revolution. Rotation is what we call a day. It's what the Earth does every 24 hours. It turns like this. It takes 24 hours for a day or a rotation on Earth. There's another term I want to talk about called revolution. That means going around the sun. It takes a year for us to do that, a year for us to go all the way around the sun like this. And back. Well, if you were on Mercury, that'd happen a lot faster because Mercury is so close to the sun. Kind of like when you're playing tetherball. Once that ball gets close to the post, it starts spinning around that post real fast. And because Mercury is so close to the post, that is the sun, it goes around very, very fast. A day on Mercury is a long time. It's about 2 months on Earth. It takes about 2 months for Mercury just to spin once and have a day. And it takes 3 months to go around the sun. So if you lived on Mercury, you'd get a lot of birthdays every year. Except you couldn't live on Mercury. It's too hot. There's no atmosphere. All right, let's move on to the planet Venus. So there's the sun, and there's Mercury. And here we go to Venus. We take one more big step, and we're there. Well, here's Venus. If that's the sun, that little tiny black dot that you see right there, that's Venus. Venus takes 7 months to revolve around the sun, but its rotation is about 225 of our days. It takes about 8 months. In fact, its day and its year are pretty much the same length. Now, Venus doesn't have any moons either, but it does have an atmosphere, but not one that you would like. The atmosphere there is so dense and so strong, its pressure would kill you. It weighs so much. That's something else. So Venus would not be a good place to move to when you grow up. Now let's move on to a planet that's a little friendlier, Earth. And here we go to Earth. One more big step and we're there. We've gone 93 million miles. Now, for those of you not familiar with the Earth, it takes 24 hours for the Earth to go around its rotation, to have a day. And it takes 365 of those days to run a lap all the way around the sun. And that's just right for us. At this distance from the sun and with the length of our day and the length of our year, oh, this is just the right place to live. It has a stronger atmosphere than Mercury, because Mercury doesn't have one, but not so strong as Venus. Why, it's just right. Just like the story of Goldilocks. Earth exists in what's called the Goldilocks zone. Everything is perfect here for life, unlike the other planets in our solar system. Oh, and also, Earth has one moon, and the moon is just the right size. If it was bigger or smaller, it would affect how we live here. If it was further away from us or closer, that would also prevent us from living here. But Earth, as I said, is just right. Let's move on now to Mars. And to go to Mars, I will take one more big step. There we are at Mars. And there's Mars. Can you see that little tiny black dot in the middle? It's about half the size of Earth. The yellow's the sun, and that black dot there is Mars. So Mars is about half the size of Earth. So it doesn't have as much gravity as we do, but it's got some, and it's got an atmosphere too. But the atmosphere isn't as strong as ours, and it's carbon dioxide. Plants would like that, but it's not a strong atmosphere. In fact, when we land spacecraft there, we start landing them with a parachute, but it's a really big parachute because there's just not a lot of air. And even then, the parachute doesn't slow it down enough. We need to use rockets to slow it down for a gentle landing on the planet. Now, Mars is kind of cool. It has 2 moons. Wouldn't that be nice? And its day, its rotation, is similar to ours. It's 24.5 hours. But it takes about 1.5 years, a little over, to go around the sun. You wouldn't get very many birthdays if you lived there. Well, let's move on now to Jupiter. Remember, 1 step to Mercury, 1 step to Venus, 1 step to Earth, 1 step to Mars. Where do you think Jupiter's going to be? So here we go to Jupiter. 1, 2, 3 big steps. 4, 5, 6, 7, 8, 9 big steps. We've gone a total of 13 yards, or approximately 13 meters, since we left the sun way back there. Look at those planets in the distance and how far away they are. Now, in between Mars and Jupiter, there is something out there. It's called the asteroid belt. That might be a planet that never formed, or a planet that got broken up, but there's lots of chunks of rock and stuff like that orbiting in between. But let's talk about Jupiter. Look how big Jupiter is compared to the sun. That big black dot is Jupiter. You could fit 100 Jupiters inside the sun, and you could fit 100 Earths inside a Jupiter. That's how big Jupiter is. In fact, you could fit 1 million Earths inside the sun. So Jupiter is a long way from the sun. Earth is 93 million miles from the sun. Jupiter is 484 million miles from the sun. And the other weird thing about Jupiter is it's not solid. You can't stand on it. It's made of gas, kind of like air. So if you tried to land on Jupiter, you'd just keep going right down to the center of it. But you know what Jupiter does have that's pretty cool? It has over 60 moons, different colors, different sizes. Can you imagine what it's like to look up at the sky and see all those moons going around at night? That'd be pretty cool. But nighttime would happen pretty often, because look how far we are from the sun. The sun wouldn't be very bright from Jupiter. And here's another interesting thing about Jupiter. It's kind of like a star, not just a planet, because stars give off energy. Planets don't. Well, Jupiter is so big and has so much gravity that its gravitational effect gives off more energy than it's getting from the distant sun. So yeah, it gets some light from the sun, but it's giving off more gravitational energy than it's getting in return. So some scientists, some astronomers would say, in some ways, Jupiter is like a star, not just like a planet. And when you lay down at night and look up at the sky, some of those stars you see aren't just a star. They're 2 stars orbiting each other. And that's very common in the sky. Sometimes there's 3 stars or more orbiting each other instead of just a single star like we have. So if you want to say that Jupiter's a star, we're kind of like those other guys. 2 stars in the same solar system orbiting together. Well, we've covered a lot of empty space as we journeyed through space between Mars and Jupiter. We've gone 13 yards or 13 meters. You may want to walk this out on your soccer field or football field at your school to see what that's like. 1 step or 1 yard was Mercury, 1 for Venus, 1 for Earth, 1 for Mars. But 13 takes you to Jupiter. and you'll see there's a lot of empty space in there. If I was doing this at night, you wouldn't see a lot of light back there from that star. But now let's go to Saturn, the pretty planet with the rings around it. And here we go to Saturn. Now you can see all those planets in the background. I'm going to take a few more steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see those stars back there? There's Jupiter, and there's all the other stars bunched up back at the sun. There's what Saturn looks like. It's pretty big too. Not as big as the sun, of course, and not as big as Jupiter, but still pretty darn big. Now we've traveled 887 million miles. That's over 1 billion kilometers. And Saturn has a lot of moons too. It has over 60 that we know of. And like Jupiter, it's made of gas. You can't land on it. Now, when I was a kid, they said Saturn had 3 rings around it because we were looking at Saturn through a telescope. But once we sent spacecraft there, we found out Saturn has well over 1,000 rings around it. They're spinning rings of ice and dust, and some of them actually spiral around themselves like braided rings. Isn't that cool? And then you mix those arcs of rings across the sky at night with all the moons. That would be an amazing thing to see if you were out there. Now, if you lived on Saturn, it would take you almost 30 years to go around the sun because it's so far away. And its day, though, on the other hand, is only about 10 hours long. So it's spinning really fast, but it's going really slow around the sun. Jupiter's kind of the same. As big as it is, it only takes 11 hours to make a day on Jupiter, but it takes almost 12 years to go around the sun. So if you're a 6th grader watching this, then chances are you'd have only had 1 birthday on Jupiter. And me, I'm in my 60s. I'd be 2 years old on Saturn. That's pretty cool. Well, let's walk past Saturn all the way out to the next planet. Here we go, out to the planet Uranus. Okay, there's the sun, and that black dot is Uranus. Now, some astronomers like to call it Uranus, because it's less embarrassing when you talk about it. But look how far we are. Can you even see those other planets back there? If I was walking this on a soccer field, I would have started at one goal line and walked out to midfield right now. We're 50 yards or 50 meters from the sun. Now, if this was at night and the sun was alight, I couldn't read a book out here. It'd be pretty dark, even with a light on. Now, how far have we come? Well, let's see. We have gone, oh my goodness. We have traveled 1,784,000,000 miles, or almost 3 billion kilometers. That's pretty far for one day's field trip. Now, there's over 24 moons on this planet, and it's our 3rd gaseous planet. Do you know it takes 18 hours for Uranus to turn? And it takes about 85 years for it to go around the sun. So you might live long enough to have 1 birthday if you lived on Uranus. All right, way in the background by that oak tree, you can see the sun, maybe if you have really good eyes. But here we go out to Neptune. Whew, I am tired from all this interplanetary travel. There's Neptune, and that black dot you see in the middle, that's what Neptune looks like compared to the sun. We've traveled almost 3 billion miles, or over 4.5 billion kilometers. We know of 13 moons on this planet, and it's our 4th gas planet. We had 4 rocky planets, followed by 4 planets that are gaseous and very large. And that's a good thing, because if we didn't have these big planets out here on the outside of the solar system, we wouldn't be able to live here on Earth. They act like a big vacuum cleaner, sweeping around the solar system and picking up debris that might otherwise get sucked into Earth's gravity and destroy us. So I'm so glad we have these big planets out here. That's one of the things that makes our solar system just right. Now let me read my notes. It takes 165 years to go around the sun out here. That's a long time. I wouldn't live to be 1 year old. And it takes 19 hours to make a day out here. We're currently at the 75-yard line, or 75 meters from the start where the sun was placed. Now it's time to walk out to my friend Pluto. A good friend of mine from the old days, because when I was in school, he was one of our planets. He's now been kind of disowned by some astronomers, and we'll talk about that when we get there. But let's take a look at Pluto. Well, if that's the sun, this little tiny dot you see there would be Pluto. Pluto's the smallest of the places we've visited so far, whether you call it a planet or a dwarf planet, whatever your preference is. Now that oak tree you see in the background is where I placed the sun. You probably can't see it in this video, but remember that ball, which is about 2.5 inches across, is sitting back there. If you were on Pluto, the light of the sun in the daytime would look like a very bright star. Now it takes Pluto 243 years to go around the sun, one revolution around the sun. Its rotation takes about a little over 6 days, about 6.5 days. Why isn't Pluto a planet? Well, astronomers started to find more and more stuff in our solar system. They said asteroids aren't planets, they're way too small. Well, what about Pluto? Is it a planet? What about a comet? So they had to decide what makes something a planet. And they came up with 3 rules. Rule number 1, has to go around the sun. Well, Pluto does that. It takes 243 years to do that one revolution, but it does it. Now, the second is, it has to be round. The asteroids are just irregular chunks of rock, so they're not round. They weren't big enough to have gravity pull them into a spherical shape. Pluto is round. It's big enough to do that. It's about 1/5 the diameter of the Earth. Here's the problem, though. The third definition was, it has to be big enough that as it sweeps around the sun, it clears or vacuums its orbital path. It has enough gravity to pull in the debris. Well, unfortunately, Pluto has kept a dirty room. It has not cleaned its room, and for that reason, astronomers said it's not a planet. During the time since we made that decision, though, we found something else out. We found that Pluto has 5 moons. And some astronomers are thinking, hey, it's got more moons than we do. So why not call it a planet? So nowadays they've settled on the idea of it being a dwarf planet. It has some characteristics of a planet and some it doesn't. But to give an idea of how far we've traveled on this journey today, 3.6 billion miles, or well over 5 billion kilometers. Now, Pluto is the last guy out here, and he's rocky as well. So we have the 4 rocky planets, the 4 gas planets, then Pluto. And you might want to research Planet X, which has been discovered recently. Now look behind me. Can you see all those planets way off in the distance, strung out between here and that oak tree? That's 100 yards that I've walked, or about 100 meters, the length of your soccer field or football field at your school. If we put the sun at one goal line, Pluto's on the other goal line. And yet in all our journey, we've only found one place that's conducive to life, and that's Earth. So if I want to find out if there's more life down there, I have to leave our solar system. I have to go find another star and its planets. So how should I do that? If I keep walking in this direction, when will I get to the next star and solar system? Well, it turns out the next star is called Alpha Proxima A. And in order to get there, we're going to have to do some more walking. Let me show you. That's what Alpha Proxima A would look like compared to our sun. Do you remember how big that yellow circle was on the other cards that represented our star? Well, this is our neighboring star in space, Alpha Proxima A. It's about 1/7 the diameter of our star, the sun. And if we walk to it at this rate, the distance is quite a bit. It is over 4 light years away. So let's take a look at where I'd have to walk to get to Alpha Proxima A. So there's Pluto, and I need to head that way, north. Now I need to keep walking. Off in the distance, you may see the roof of a house. I need to go up to that house and knock on the door and ask for a glass of water, because I'm in for a long journey. Off in the further distance, you'll see some high-tension power lines, perhaps. It's past that. You might even see some mountains in the distance. I would have to walk from here, east of Redding, California, past Portland, Oregon, clear to the Columbia River on the border between the states of Oregon and Washington to get to Alpha Proxima A. With the best rockets we have, it would take 100 years to get there and 100 to get back. So stay right there. I'll go as fast as I can. I got bad news for you. Alpha Proxima A doesn't have any planets. There's nobody home. I'm afraid, folks, we're alone. We're on this wonderful planet, this beautiful planet that you see around us. It's the only place in our solar system where we can live. And going to another planet, gonna take us way too long. We'd never make it. So, let's take care of this one. Well, what might it look like if we were really out in space, looking back at our own star, the sun? Well, we're about to find out, because I'm going to do this same 100-meter walk at night, using this flashlight to represent the sun. So we're now 1 meter away. That might be how the sun would look if we're at Mercury. 1 more meter, we're at Venus. And 1 more, and we're at Earth. And doesn't that look like about the size of the sun from Earth? We're now 3 meters away from that light source. Let me keep walking. There's how it would look from Mars, much smaller. But let's walk out to Jupiter, which was 13 meters from the sun in our scaled walk. Now we are 13 meters away. Look how tiny that light looks. And we're only at Jupiter. We still have a lot more planets to go through. So we see some lights from houses and things like that. Those are much further away. That might be how other stars looked. But that bright one there, that would be our sun from Jupiter or from one of its moons. Now we'll venture out another 12 meters, 25 meters to Saturn. And there we are, we're at Saturn, 25 meters away from that flashlight, and you can see it barely shining there. Still bright, but not bright enough to read by. The light that you're seeing to light my face is coming from a second flashlight that I have mounted in front of me. But that light that's behind me, that wouldn't provide enough light to read out here on Saturn. Let's go out to the 50-meter mark at Uranus. hard walking out here in the darkness. There's that light right there. That's our sun from 50 meters away at the planet Uranus. We have another 25 meters to go to get to Neptune at the 75 yard or 75 meter mark. There it is. You can see a tree there out in the middle of space. What's that tree doing there? But there's our sun way back there, that little tiny dot of light. Not much brighter than the other lights that we see in the distance. We're now 75 meters away. We're on Neptune. And now we're going to finish our journey by going the full 100 meters out to Pluto. And there we are. Boy, our sun doesn't look much different than some of the other lights that we see out there. If you're on Pluto, the sun would simply be a bright star, not much more than that. So there we are, 100 meters away, out on distant Pluto, looking back at our light, the sun. And even though it's right there, it would appear to be nighttime, even in the middle of the day, because the sun would offer so little light for us. So thanks for joining me on this great walk through our solar system, and I will see you later.